Okay, so here we have T5 paper 1. I'm going to do the June 16 calculator and non-calculator exams here. So this is the T5 paper 1 non-calculator. Okay, so question 1, very straightforward, line of symmetry to go there. Question B1 and B2 is to do with lines of symmetry and rotational symmetry. Now, if it was a normal shape, in some of the other questions you get tracing paper to get rotational symmetry and all, but we should know that any regular sided shape has the same number of rotational symmetry. So for example, a 7-sided shape has rotational symmetry 7, a hexagon which is 6-sided would have rotational symmetry 6, and so on and so on. A 12-sided shape is called a dodecagon, that would have a rotational symmetry of 12. Okay, all the lines of symmetry, so I've thrown the 7 in, that 1 goes to there, you can see the 2 goes there, and the key thing to note is that it starts from like an end point and it goes through the middle underneath. So from the middle to the end, from the point to the middle, from the middle to the point, and so on. So that's got 7 lines of symmetry in that shape. Okay, page 2, as we can see, is about reflection. Okay, I'll take this opportunity again to remind you that when we're doing the axes, that the x lines go up and down and y lines go across, but this is just a straightforward mirror line, and all we have to do is just to draw it the other side. This one's a wee bit more difficult. We just have to make sure we count to the line, so make sure your shape is exactly, so this point is reflected there, 2 away, this point is 2 boxes away, so it's up there, this point stays exactly the same, that line there is reflected there, and this line here is reflected there. So just take your time, make sure your shape is exactly the same as that. Question 3 is a question about a quiz. It says there are 12 questions. Each time you get a question right, you get 4 points. Each time you got a question wrong, you lose 2 points. Fairly straightforward. 12 answers correct, 12 fours is 48. Next one, part B. 8 correct and 4 wrong gives you 32 minus 8, which is 24. You'll note that I've done the workings out. Make sure you do the workings out. And part C, the only difficulty in this question is you must use all 12 answers. So for example, you could actually get 30 by not using all 12, but you must use all 12. So the answer would be 9 correct, which is 36, 3 incorrect, which gives you an answer of 6, and you take them away. Again, boys and girls, be very careful to show all workings. Any question that has more than 1 mark requires workings. Okay, question 4 is an estimating question. 98 becomes 100, 6.9 becomes 7, and again 100 multiplied by 7 gives you 700. I might just take this opportunity just to put this question out to you to see how you get on. What would the answer be to estimating of 99 divided by 0.2? Well, let's rewrite it as 99 divided by 0.2. Remember the 0, we put the 0 to the top, stroke that out, and then that becomes 990 divided by 2. 2 into 9 goes 4, remainder 1. 2 into 19 goes 9, remainder 1. And 2 into 10 goes 5. So the answer to that would be 495. Now I'm just putting that question out again to make sure, even though it's written as that, rewrite it this way so you can see that it's easier to put that way. Okay, so even if the sums comes like that, rewrite it like that so you can put your 0 at the top and stroke it out there. Very straightforward question on estimating question 4. Question 5. Now, just to reiterate, boys and girls, the only time for probability we use this information is if they give us the words. We should not be writing unlikely, very unlikely, certain, likely for any other probability questions, only when it states clearly here these are your options. Any other time, probability will always be a fraction answer. Okay, you buy a lottery ticket and win the jackpot. Well, it's not impossible, it's very unlikely because large number of tickets are sold. You've got to put an answer in. There's a large number of tickets sold, there's many people buy tickets, you just can't write very unlikely. Christmas Day will fall on the 25th of December this year. Well, that's absolutely certain because Christmas always is on the 25th of December. Again, you need a valid reason for that. Question 6 again, fairly straightforward question on decimal places. 3 decimal places, you go and you put your R with the third number, box it all off, the 4 won't change it to give you that answer. Go to the third number, which is the 8, box it off, the 7 will change it, so you think that 98 would become 0.099. Now, let's do significant figures when we're here. What would that answer be if I wanted to do this to 2SF. Okay, arrow to the second number, box it off. The 4 won't change it, so the answer there becomes 63 to 2 significant figures, or 63.0000. Okay, now what about this to 2 significant figures? 0.0987. We do not, as you know, include numbers as zeros at the start, so the second significant number is there. Box it. Will the 7 change it? Yes. So that 98 becomes almost 99. So in this occasion, the answer for that to 2 significant figures is 0.099, which just happens to be the same as the answer that we had for the decimal places. Okay, please learn them, boys and girls, about decimal places and significant figures. A couple of easy marks just for learning that. Again, standard question, non-calculator question on the square root. I've done loads of these in the T5 booklet 1 video. So again, the square root of 75, 64 gives you 8, 81 gives you 9, 73 is somewhere in the middle. Take that line down and you'll see it's 8.5. Again, practice lots of those in the video, in video 1 practice paper, so have another look at that video. And so, folks, we get to the sort of harder questions. These are the 4-mark questions we've got to get right. Now, Jack has been asked by his teacher to investigate 2 algebraic expressions, PQ plus R and P brackets Q plus R. He puts the values P1, Q3 and R4 into the expressions and finds that he gets the same answer. Show that that is true. Well, really what they're asking you is, do you know that PQ means P times Q? So what you do is you multiply P and Q and you add on R. So here, P is 1 times Q, which is 3. 1 times 3 is 3. Plus the 4 gives you 7. So that there gives you an answer of 7. Okay, now substitute this in. 1 to go there. Q is the 3. R is the 4. 3 plus 4 is 7. 1 times, brackets mean 7. 1 times 7 gives you 7. Okay, now that's how we do that. Now, however, this is the key question we've got to get. Jack says that this means that PQ plus R is the same as that. Now that is not always the case. Okay, so this is the reason why. That means P times Q plus R. However, when you multiply with the brackets, P times Q gives you PQ. And P times R gives you PR. So that gives you PQ. This gives you PR. That's not the same as PQ plus R, because that gives you PQ plus PR. Okay, so when you're multiplying out brackets, you've got to think about what would happen when you multiply them out. So for example, P onto R plus S. When you multiply that out, that gives you PR plus PS. That's not the same as PR plus S. Okay? Got to have a wee think about that question, guys, and understand what exactly that's talking about. Okay, so that means, that explains why Jack is wrong on that. Okay, so question 10 is a table about spinners and a fair dice. It's got 1, 3, 5, 7, 9, 11 along here for the dice, and you've got 2, 4 and 6 for the spinner. Now the key thing is, in a game the spinner is spun and the dice is rolled, the 2 scores are added together. So what you need to do, 2 plus 1 is 3, 2 plus 3 is 5, 7, 9. Now you've got to make sure you count them up correctly to get your 2 marks. Part B is related to this table. What is the probability? Probability is fractions. That is sum means when you add them, of the 2 scores is greater than 12. So let's count all the numbers greater than 12. 1, 2, 3, 4, 5, 6. So that's 6 over them total there, that is 18. So the answer to that there is 6 over 18. Now, we've made that smaller. If you divide that by 6, if you divide it by 6, 6 into 6 gives you your 1. And 6 into your 18 gives you your 3, 1/3. Okay, just watch for those normal answers. Now, if for example part C, if I write in part C, this is a question a lot of people seem to make mistakes on and can't understand for probability. So if I make this question part C, I'll just take that colour there. Let's say we wanted to find out how many, what would the estimate be for if we threw, for argument's sake, 80 throws. and we wanted to find out how many times the number, let's say the number 9 appeared. What you do is you count how many 9s there is. There's 1, 2, 3. There's 3 9s. So for that question there, you have to find 3 9ths, or 3 over 18, 3 18ths of 80. So what that means is you divide 80 by 18 and multiply that number by 3. And that gives you that gives you the rough estimate how many times you would expect the number 9 if it was thrown 80 times. Okay? There's loads and loads of examples in past paper questions of those. Just have a good look and see if you can find the answer for that. Okay. Okay, for question 11 now, what we have is we have a question about really substitution. Okay, it's basically substitution. So the surface area of a cylinder can be found using the formula S equals 2A plus C. So you want to find the value of C when S is 23 and A is 3.5. Write the formula out, put in the number S is 23 equals, always remember to put a rake equal signs in when you've got equations at all. 2 times A is 2 times 3.5 plus C. So 2 times 3.5 gives you 7. 23 equals the 7 plus C. So what that means is, what do you add 7 to get 23? Well, 7 plus 16 is 23. That's how you get that answer. Okay, now for question 12, this I find is a bit of a trickier type of question. Okay, basically what they're doing is they're giving you this sum here. They're telling you from that sum to find the answer for this. Now, there's 2 ways of doing it. I'm going to show you both ways. I like this way, but a lot of people use the other way. So I'm going to show you this way first. Basically what happens, that number there is the same as that number. This number here is the same as that number. So your answer is going to involve this number here. So basically what you do is this. I make that number something handy like a 6. I make this number something handy like an 80. And I just do 6 times 80, which gives me 480. Just move that all one away to the road. 480. Okay? So that gives me 480. So I go up to my sum up here, and I looked and see, how can I make that close to 480? Well, if I stick the decimal in there, that gives me 543. So that's the only one that's close to 480. For example, if I put the decimal in there, that'll be 54 point something. Or if I put the decimal in here, it would be 5.4. So that's no good. So the decimal has to go into there. So that gives you 543.15, which I'll just show you now. That's the answer for that. Now, a lot of people do it the other way, and this is quite a good way as well. I'll just shorten that down, and I've just written the number here. So there's again, there's the sum that they give us. That's the sum. Okay? That's the original sum. And they've asked us to work this out. Now, what you do is this. You write the sum out again. You write the new sum out underneath it. So 639 has become 6.39. 8.5 has become 85. Now from that, what you do is you go to this and you'll realise that the decimal, which is here, has moved 2 to the left to get you to there. So it's there, 1, 2, which is there now, which is 2 to the left. The decimal, which was here, has now moved to here, so that's 1 to the right. So your answer here, your decimal must move the 2 to the left, and then the 1 to the right, to end up at 543.15. That's how a lot of people do it. I don't mind which way you do it. Sometimes that may be a bit easier than this way here. Okay, it's very much a preference and whatever you think. So all you do there, just to reiterate, for the other one, is you write out the initial sum, which is this. You put the new sum that they want you to find underneath it, and you work out how far left and how far right, and then your answer has to go the same, 2 left and 1 right to get you to here. Okay, that's how you do those multiplication questions. However, for the dividing sum, the only way that I would advise you to do it is to actually do it like a rounding question. So let's see what numbers we're dealing with. 54315 is this number here. 850 is to do with this number here. So our answer must have something to do with this. Must have something to do with 639. Okay, so what I've done again, I've rounded 543 to give me 500, 850 to give me 800. I've stroked out the 2 zeros, so I've now got an answer of 5 divided by 8. Well, 5 divided by 8 is just a wee bit more than a half. So the answer is 0 point something. Now, I don't have to know the answer. I just have to know it's 0 point something. Now, because this number is the number that's left, I have to make that 0 point something. So the answer for that must then be 0.639. The 639 comes from these initial numbers here. Okay, and that's how you deal with multiplication and dividing of those type of sums. Okay, multiplication is probably easier to do left than right. For the dividing sum, you've got to just round them up or down and so on, and then work out what the answer would give you left over. Okay, so I've just done another example here just to see, just to try and show you how to use this question to do with mathematical facts. So this is the mathematical fact. This was the fact that I've just after creating. 25.5 multiplied by 467 gives you 11,908.5. Okay, this is just playing up a wee bit this. Okay, now I want to find 0.25 multiplied by 4670. Now here's how I did it. Okay, I wrote this number back up here, 0.255, and I wrote this number here underneath it, 4670. Now, from the decimal here, we can see that it's there at the minute, it's here at the minute, and it's moved back 1, 2 to get to there. So that's 2 to the left. The decimal, if we can't see it, is there. It is now moved till here, which means that it's now moved 1 to the right. So it's moved 2 to the left here, 1 to the right here. So if I move it 2 to the left, 1, 2, and then 1 to the right, you end up with an answer of 1190.85. That's the answer for that sum there. The dividing sum, as I told you before, you just round them up to make it easy. So you have to work out that number belongs to this. This number belongs to that. So your answer must involve these three numbers here. So 119 gives me roughly to 100. 25 gives me 20. 25.5 gives me 25. 100 divided by 25 gives you 4. So your answer must involve 4 something. So I go up here, stick my decimal in. It gives me 4.67. Okay, just have another think through those questions. Check previous past paper answers and see if you can work those out. Okay, again, a straightforward question about trapeziums and triangles. They want the trapezium of STUR, which is this trapezium here. You don't have to turn it around. That's the top, that's the bottom, and that's the height. The height is 7. So 9 plus, again, non-calculator, 9 plus 13 is 22. 22 times 7 over here, I've done a sum to give me 154. I'll just show you how to do it. 7 times 2 is 14, put down your 4 and carry your 1. 7 2s is 14 and 1 is 15. So 154 divided by 2 gives you 77. That's the area of the whole trapezium. Now, because they want the quadrilateral, the same type of question that we've answered in previous videos, you must take off this triangle. So the area of a triangle is base times height divided by 2. So that's 3 times 9, which is 27, divided by 2 gives you 13.5. So what we have now is we have our 77 here, minus our 13.5. Let's do that as a sum. I'll make that a bit bigger so you can see it. So 77 minus 13.5 as a sum. 5 goes in, that becomes 10 to give you your 5. You knock that down to 6. So 77.0 minus 13.5 gives you an answer of 63.5. Another 3-mark question on estimating with the decimal at the bottom. Fairly straightforward stuff again. This number becomes 300. This number becomes 4, and that becomes 0.5. So 300 times 4 gives you 1,200, divided by 0.5. Stick your 0 at the top, get rid of this 0 at the bottom. So you're now left with 12,000 divided by 5, which gives you 2,400. And that's the answer for that. And finally, we've got question 15. Obviously the hardest question because it's the last one. A 4-mark question. Okay, so let's underline the important things. 90 pupils, 60 are girls. Well, if 60 are girls, 90 girls, or 90 people, 60 girls, 30 must be boys. Got to have work-ins. You've got to give the examiner at least get an opportunity to give you a couple of marks. There'll be a mark for identifying 30 boys right away. The probability that a girl gets a part is 0.35, which is there, and the probability that a boy gets a part is 0.60. 0.6. So this is the information I've got here. How many pupils are in the school play? Well, what you have to do, because 0.35 of the girls get a part, you have to find 0.35 of 60. Now, without a calculator, as you know, 0.35 is 35 over 100. So what that means is it's 60 divided by 100. Now, we're dividing by 100, the decimal moves twice. 1, 2, to give you an answer of 0.6. And then you do 0.6 times 35 as a long multiplication. 5 sixes is 30, but down your 0 and carry your 3. 5 zeros is nothing, and down your 3. Put your magic 0 down, then 3 sixes is 18, but down your 8 and carry your 1. Stroke out that 3, that's gone. 3 noughts is nothing, and 1 is 1. To add that up, to give you 0, 11 and 2. So that gives you an answer of this part here, 21.0. Okay, because you put your point back in. Over here for the boys, again, same thing as before. You turn 0.6 into 6 tenths. So 6 tenths of 30 is 30 divided by 10, which is 3, times the 6, which is 18. So you've got 18 boys, 21 girls. You add them up to give you a final answer of 39. And that is the end of the non-calculator paper, boys and girls. Okay, welcome back. So this is the calculator paper, T5 paper 2 in 2016 June. Okay, so I'm going to run through this question again, this paper to see how we get on. Okay, so question 1 is a question on thermometer. With any of these type of questions, the key thing to work out is what each one of those is going up in. So this here is going up in 0.1. That's 31. This is 32. So that's 31.1, 31.2, 31.3, and so on. Tell the examiner you know what you're doing. Anytime you've got any scales or any grids, make sure you tell him or her what it is you're going up in. So they're going up in 0.1, and that gives you an answer of 32.7. Okay, part B, write down the weight shown on the scales. Again, let them know that you know what it's going up in. That's 0, that's 1. So they're going up in 25s, 0.25s. Okay, so you find your way around and you realise that's 4.75, which is here. Use your calculator to add on 3.5 onto that to give you an answer of 10.25, and that gives you that number there. Okay, again, very important to show the examiner you know what each one of those is going up in. Next question is about miles and kilometres. We should know how to get from kilometres to miles and miles to kilometres. So they've actually told us here in this one, we're lucky, that to go from miles to kilometres, we know that, but we already know that you divide by 5 and multiply by 8. We should know that from our grid when we do this, and that's miles and kilometres, and then kilometres and miles. We should know that. They've told us anyhow. So 48 divided by 5 multiplied by 8, it gives you 76.8. Now please show your workings. This one over here, what they're really asking you to do is to say this is 30 miles. This here, they're saying the sign shows the speed limit in miles per hour for some roads in Northern Ireland. Mike says that's approximately 50 kilometres. Show that he's right. So really what they're asking you to do is, can you turn 30 miles into kilometres? Now to turn miles into kilometres, again, divide by 5 multiply by 8. So 30 divided by 5 multiplied by 8 gives you 48, which is nearly 50. And fill the blanks in. To turn kilometres to miles, which is the other way around, we divide by 8 and multiply by 5. Fairly straightforward stuff if we can remember our information on turning miles to kilometres. 2, 4, 5 marks for that, just for knowing miles and kilometres. Okay, please learn that, boys and girls. Question 3, registration fee of £12 plus £3 per week. So for 52 weeks, you have 52 times the 3, then you add on the 12 to give you an answer of 168. Question 4, a typical question on spinners. The easiest thing to do is to write down the numbers and how many times they appear. That's the easiest thing to do for later on. So 1 appears once, 2 appears 3 times, 3 appears twice, and 4 appears twice. And I've written 8 here because there's 8 sets of numbers. So the answer for that one is 2. The answer is 3 and 4. Write down a number that a spinner cannot land on. Well, any number that's not on the spinner. So you could pick 5, 8, 10, any number at all. And part D, is the spinner more likely to land on an odd or an even? Well, there's 5 even numbers, there's 3 odd numbers, so more likely to land on even. Now this is the question here. This is the question we all seem to struggle on with the times. The spinner is spun 400 times. Estimate how many times you would expect it to land on the number 2. Well, if you go back up here, you'll see the number 2 appears 3 times. So that's 3 eighths. So really what they're asking is, can you find with the calculator 3 eighths of 400? So 400 divided by 8 multiplied by 3 gives you 150. So if it was spun 400 times, you would expect the number 2 to appear 150 times. That, boys and girls, is a fairly standard probability question. Fairly standard probability question. Learn that there. That doesn't ask for the fraction, it asks for a number at the end. That's how you know the difference. And bear in mind as well, boys and girls, that that's not a question about even or uneven or likely or highly likely. That's a probability question. The only times you will use the words like highly likely, unlikely, certain is whenever they give you those options. Otherwise that you're always dealing in probability. Question 5 is symmetry question and rotational symmetry. There are 4 marks for this, boys and girls. Please use tracing paper. So for this one here, they want you to shade a square in. So you get your tracing paper, you trace round this, and you make sure that when you have it, if you fold it in half, that this bit here fits on top of that one. That's how you check it. This one here, tracing paper is so handy for this. You need tracing paper. Ask the examiner for the tracing paper. We were given this, and what I did is I drew them, and then I moved it round on the tracing paper to give you this, and moved it round again, and I give you that. That's how you know exactly where they go. Please ask the examiner for tracing paper and use tracing paper, because 4 marks, boys and girls, for that is quite a lot of marks out of 50. Okay, this is sort of a relatively straightforward question. The key thing to note is that there are 20 balls. 4 are blue, 6 are green, and that means 10 are white. So a ball is taken at random. You have to work out where they go on the grid. Really what they're saying is there's not. That's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1. You need to mark them in. And the blue, there's 4 blues. So that's 4 out of the 20, which gives you 2 over 10, which is 0.2, which is there. That's blue. Green is 6 out of 20, divided by 2 gives you 3 tenths, which is 0.3, which is there. And white, there's half of the whites, which is 10 over 20, which is 5 over 10, which is a half, and the white goes there. Okay, remember, they're going up in 0.1s. You need to fill them in because that's 1 and that's 0, so you need to know what they're going up in. Question 7. Work out the value of P when A is 4. So that's just 5 4s, which is 20. Part B, work out Q when B is 6 and C is 3. So that's just simply 3 times 6 plus 2 times 3. 18 plus 6 gives you 24. Again, easy marks. Part C. Now this is where it gets a wee bit more interesting. You need to make sure you lay it out properly. It's all about the layout. 2D means 2 times 2, which is there. That minus, stick it in separate. Put that minus in. That E becomes 3, which is there. Then that minus is separate. This minus here, stick it in there. And then you've got your 4, and then your bracket's a half. And when you put that into the calculator, 2 times 2 is 4, minus 3, minus 4 times a half, which is 2. If you put that sum into your scientific calculator, you'll end up with you'll end up with the answer, which is minus 1. If you write that out properly, you'll end up with minus 1. Please take your time. Make sure you use the signs properly. That minus goes in by itself, and this minus goes in by itself. Please don't try and do too many things at one time. I might just take this example here. I might just use this opportunity to do a similar type of question, just to make sure we're doing it correctly. Let's say A was 2 and B was minus 3. So I want to find out what 2A minus 4B is. So what you do is you do 2 times your 2. That minus is separate. Then your 4 times your minus 3. Okay, so in your calculator, if it was non-calculator, 2 times 2 is 4. That minus there, now 4 minus 3 is minus 12. That minus belongs there. So if 4 minus minus 12, 2 minuses give you a plus. So that really means 4 plus 12, which is 16. Okay, be very careful. Keep them signs all separate. Don't include them with these here. Do one thing at a time. Question 8 is an enlargement question by a scale factor of 3. So, tricky enough type of question. This is 4, so this now needs to be 12. You'll notice that I put numbers on it here to help myself. So that's 4, so 4 threes, is this going to be 12 now? Now, this one here, this line here is like 2 on the diagonal. So this diagonal now needs to go 6. However, what you need to do is count across. You see where it goes 1 across and like 2 up. So like that's 1 box across and 2 up at that diagonal. Well, 1 times 3, that means that must go 3 across to here. 1, 2, 3. And then it's 2 going up, which means it must be, if you multiply 2 by 3, which is 6. So 1, 2, 3, 4, 5, 6. That's why that point goes there. So it's on the diagonal of 2, but it's 1 across and 2 up. So if you multiply that by the scale factor of 3, that gives you 3 across and 6 up. That's why that point is exactly there. And similarly for this here, it's a diagonal of 2, which means we must have a diagonal of 6. But again, it's gone 2 across. So this time you multiply that by 3, which gives you 6 across. And then it's 1 up here. If you multiply that by 3, it gives you 3 up, which is there, which gives you that exact diagonal. And then you join it down here, which would be 9, which is 3 threes, which is 9. Practice that question there, folks. This line's easy. It's these ones here we have to think about how you get from there to there. Okay, part B is a crucial question. We cannot get this question wrong. Everybody, the last time I gave this question, got it wrong. Read it. How many times larger is the area of the large shape than the small shape? The area. Now, the examiner, everybody writes down 3. Now, it's a scale factor of 3, but because it's area, it's 3 squared. So 3 squared means 3 times 3, which is 9. If the scale factor was 5, the area would be 5 squared, which would be 25. Please learn that question. That is 2 easy marks for nothing, if you learn what the question is about. If the scale factor was 6, the area would be 6. It wouldn't be 6 times big, it would be 6 squared. 6 sixes is 36. Please learn that question and watch out for it in the exam. Now, this is the speed, distance, time question. We have got to get these questions right. Eileen leaves home at 6 and goes for a walk. She walks at an average speed of 4 kilometers an hour for 90 minutes. How far has she walked? That's distance. So we put in our formula, we cover distance, and that means speed multiplied by time. So the speed is 4 multiplied by the time, which is 90. Now watch this, folks. They want to trip you up. If you're doing 90 minutes, it's 4 times 90, but then you have to divide it by 60 because you're in minutes. Or else if you wanted to turn minutes into 1.5, it's 4 times 1.5. Okay, either way the answer gives you 6. But how to get 6? You either do 4 times 1.5, which is 1.5 hours, which gives you 6. Or if you want to keep it minutes, it's 4 times 90, but you must divide it by 60. It's not 4 times 90 by itself. 4 times 90 divided by 60, either way it gives you 6 kilometers. So if she's walking for 4 kilometers an hour, it makes sense that in an hour and a half she'd have walked another 2. The 30 minutes is like 2, so either way 4 and 2 gives you 6. Either this way, 4 times 1.5, or 4 times 90 divided by 60. Either way gets you 6. Okay, now, again, I keep emphasizing this. For any of these graphs, you must work out what each one of these barriers are going up in. Now that's easy because they're going up in 1s. These times at the bottom are either going up in 2s, or 3s, or 4s, or 5s, 10s, 12s, or 15s, or 20s. They're going up in any one of those because they go up to 60. Now look, that's 6. That's 7. So they're going up in 15 minutes. 6:15, 6:30, 6:45, 7 o'clock. They're going up in 15 minutes. We definitely will need that for later on. Okay. She stops for a rest. She runs back home and arrives home at 8:30. On a grid below, draw the distance time graph. Okay. So we know from the top that it took her, she walked for 90 minutes. So she left home at 6 o'clock. She walked for 90 minutes, which is 7:30. So that's her there. She walked, remember, 6 kilometers. So that's that diagonal line there. She then rests for 15 minutes, which is one of these barriers. So she rests there. And then she arrives home at 8:30. So we need to go back down to know that's 8:30 and do that. Okay. What is Eileen's average speed as she runs back home? Well, average speed is distance divided by time. So her distance back home is 6 divided by this here. From this 7:45 to 8:30 is 45 minutes. From this is where she starts back. So that's 45 minutes. So 6 divided by 45 multiply by the 60 gives you 8. Or if you wanted to do 6 divided by 0.75, which is 3/4, either way the answer will give you 6. Okay, be very careful. If you're dealing in minutes, always get back to minutes. So for this question here, it's a recipe for some scones. This is the information you need. It doesn't tell you how many scones you have, so you've got this information here, and it's saying Linda has only 100 milliliters of milk. So in other words, she had 125 and now she's only got 100. Okay, so you need to work out how to get from 125 to 100. So the formula is all these numbers must be divided by the 125, because 125 divided by 125 gives you 1, multiplied by 100 gives you 100. So all these numbers here are going to be divided by this and multiplied by that. So this number here will be 340 divided by 125 times 100, and so on to get these answers here for these missing ingredients. Okay, a fairly straightforward question, but actually quite a lot of workings out to do it. The key thing to note is P is a prime number greater than 2. Well, we clearly must know our prime numbers. Write them in: 2, 3, 5, 7, 11, 13, 17, 19. And Q is an even number. Well, any even numbers are 2, 4, 6, 8, 10, and so on. Now here's the key thing. Which of these statements below describes this? That means P multiplied by Q plus 1. Okay, so if, for example, we take any number. For example, we take our prime. We can't use 2 because they're saying don't use 2. So we take the prime number as 3. So if we put P in here as 3, we take Q out of Q to be 10. So 10 plus 1 is 11 times 3. 3 11s is 33. That's an odd number. Okay, that's odd. Let's try another one. I've used 5 now. 5 is the prime number. In the brackets I've used 4 as the even. 4 plus 1 is 5. 5 5s is 25. That's also an odd number. So based on these two answers that I've used, I think we can always say that the answer will always be odd, because our two answers were 33 and 25. Now, just so you always know, if you multiply an odd number by an odd number, odd, 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 it always gives you odd. But give the examiner at least 2 examples to let him know or let her know exactly what you're doing. Okay, question 12 is the usual question about mass, density and volume, because it's asking about density. As I've said in previous videos, if mass or density appears, really what they're asking you to do is to find the volume. And the volume is the area of this shape here, the front of it, multiplied by that. So no matter what it's to do with mass or density, you must find the volume first. So the volume is the 40 times the 37 to give you this. You're looking to find the density, so cover density, so that's mass divided by volume, which the mass on the question is this, divided by the volume to give you an answer of 3.58. I always round that up to 1 decimal place to give you 3.6. Okay, and the last question is making V the subject. Now, it's an awkward enough type of one, so I'll write it out here so we can see it. So the first thing to do is to write it out. So you've got 2s equals, now you see that t, I'm going to take that t and put it in front of the uv. So I'm going to now do t brackets u plus v. Now I've done it here actually, you can see that I've done it here, but I'm just going to write it out to make it a wee bit easier to see. So you've got 2s equals, now t times u gives you tu, t times v gives you tv, and you've got the plus. Now what are we looking to find? We're looking to find v. We're looking to find that v. Okay, so as we were doing equations, the first thing I always say is to do a rake of equal signs. Equal signs, because equal signs keeps the barriers. So we want to bring this over first. So you've got 2s minus tu equals tv. Now I want to get v by itself, so I need to divide it all. I need to get rid of that t. So that t is multiplied here, which means it's going to be dividing. So I now do 2s minus tu divided by t, which gives me v. Now I can write it fancily here. Just go back. So that's the answer there. It's 2s minus tu divided by t, which I've done. Or if you want to write it fancy like that, that's fine. Now, very difficult question, boys and girls, but practice how to make the subject.